We've heard about terraforming the Moon and Mars as we attempt to colonize space. But what about Venus? If we did manage to terraform our neighbor, one day it could look like this. Could we live here one day? How different would it be from life on Earth? This is What If, and here's what would happen if we terraformed Venus. Believe it or not, Earth and Venus are very similar. At times, Venus is even referred to as Earth's sister planet. They're both roughly the same diameter, have the same mass, same gravity, and are both made out of the same material, a central iron core and a rocky mantle. Unfortunately, the comparisons end there. Unlike Earth, Venus is extremely hot, has an incredibly dense atmosphere, and toxic fumes on its surface. What would we need to do to make it habitable? Scientists and astronomers have been theorizing how to terraform Venus for over half a century. The two biggest issues that need to be solved are the atmosphere and the temperature on Venus. Currently, the surface of Venus is a sweltering 462 degrees, hot enough to melt lead. And the atmosphere, made up mostly of carbon dioxide, is 93 times as heavy as Earth's. One proposed way of altering Venus's atmosphere is to bomb it with hydrogen. Hydrogen bombs, when reacting with the carbon dioxide in the atmosphere, would create graphite and water. This would fall down to the planet's surface and cover 80% of it with oceans. Mind you, they wouldn't be nearly as deep as Earth's oceans. Venus would only have 10% the amount of water that Earth has. This would take a lot of hydrogen. The only way we could get enough is if we were to harvest the resource from Jupiter or Saturn. This approach would also require iron aerosol, a material that can be mined from asteroids. If all went according to plan, the dense carbon dioxide atmosphere would be reduced to being just 3 times as heavy as Earth's. Okay, that's manageable. This would also help clear the clouds of sulfuric acid that hang over the planet. Okay, the atmosphere's clear. Now, what about the temperature? One way to cool the surface is with solar shades, a series of small spaceships or one large lens that would divert the rays of the sun. These solar shades could be placed on the surface of the planet or in the atmosphere, slowly working to cool down the planet and reduce radiation, another issue that would need to be resolved before we started living on Venus. In addition to solar shades, NASA thinks that we could build floating cities above the clouds of Venus. These would work as a safe living space as we learn and attempt to terraform the environment. To cool the planet even more and to speed up the process, cooling pipes could be put on the surface of the planet. These pipes would take heat from the surface and bring it up to colder parts of the atmosphere. Now we have a suitable atmosphere, a proper temperature, and clean air. But there's one other huge issue that humans might have if they move to Venus. They'd have extremely long days and nights, since Venus rotates once every 243 Earth days, meaning a day on Venus is 5,800 hours long. Not to mention, it's the only planet in our solar system to rotate clockwise, meaning that its extremely slow sunrise would happen in the west, and sunsets would be in the east. We could create the illusion of a 24-hour day cycle by using massive mirrors and having them rotate to reflect the sun. If this managed to work correctly, Venus would feel just like home, with maybe a touch less gravity. After all this, Venus would finally be habitable. Sure, the planet would rotate differently and you'd get a different view of the sun, but it could be another place for humans to live. Scientists theorize that it could be a backup planet one day. Studying more about Venus could teach us something about Earth. Venus suffers incredibly strong greenhouse effects, the cause of its extreme temperatures and dense atmosphere. By learning more about cooling this planet, it may unlock the secrets to cooling our own and maybe make our home last even longer. Okay, let's say we're ready to move to a terraformed Venus. Well, let me ask you, how do you think we should run it? When we imagine setting up new societies in new worlds, establishing a fair and transparent system like democracy would be crucial. Here on Earth, democracy means trust and certainty, especially when it comes to counting votes. The 2024 US presidential election has wrapped up, but the work isn't done yet. Our democracy counts every vote, and that's not something every country can say. At this stage, ballots are still being counted across the country by teams of local officials and volunteers from both parties, working together to ensure accuracy. The process is based on checks and balances, same principles that protect democracy. After the votes are counted, it's still not over. There's a final step called certification, where a team of impartial workers double checks every result. This isn't a quick process, it's a careful one. Every ballot matters, so the focus is on accuracy, not speed. That's why some states might take longer than others to finalize their counts. And candidates have the right to challenge the certification in court. Once these challenges are settled, then the election results are final. By December 17th, every state will have certified their results. Systems like this one, which protect freedom and give everyone a voice, take time to guarantee fair results. The last thing we want to do is make a mistake by rushing. But while this democratic process unfolds on Earth, let's set our sights back to the sky. The last time humans landed on the moon was over 50 years ago. Maybe it's time we paid another visit.
What if we humans could live somewhere outside of Earth? Say the moon. Obviously, we can't just pack our stuff and move there today, but what if we terraformed it, reshaped it into Earth's image? How long would it take us to turn our natural satellite into a habitable place? What would this Earth moon look like? Would this even be possible? This is What If, and here's what would happen if we terraformed the moon. Wondering why we chose the moon and not Mars? With water ice buried beneath its surface, the red planet seems to be the best candidate to serve as our second Earth. But with zero experience terraforming, we should consider colonizing our natural satellite first. It gets twice as much sunlight as Mars, and it's just a 3-day trip from us. In short, it would take us less time and money to construct a decent Earth on our moon. So, how exactly do we engineer a habitable planet? Just to be clear, we're not talking about building a permanent moon base. We'd go nuts and actually transform the moon into an Earth, just a smaller one. For starters, we'd need to build an atmosphere. And here's the fun part. To do that, we'd need to bombard our moon with 100 water ice comets, asteroids. We'd find them flying all around the Earth. These comets would crash into the moon's surface. They'd fill the moon's plains with water and disperse carbon dioxide along with water vapor and a little bit of ammonia and methane. All these gases would gather near the surface, creating an atmosphere. The newly formed seas would reflect much more sunlight, making the moon appear 5 times brighter when seen from Earth. These asteroids would also give the moon a momentum. They'd make our satellite spin close to an Earth-like cycle. The more comets we batter into the moon, the faster it would rotate. A lunar day would drop down from an incredible 28 Earth days to just 60 hours. Since our satellite wouldn't rotate on its axis at the same rate it orbits the Earth anymore, it would no longer be tidally locked to our planet. For Earthers, this would mean we'd be able to see the dark side of the moon, although it wouldn't be dark. But how do we save the newly built lunar atmosphere from being stripped away by solar winds? We'd have a couple of options. The first one is easy. Moon's own rotation would generate a dynamo effect. That dynamo could awaken the moon's once active magnetic field that would keep the atmosphere in place. If that doesn't work out, we'd have to place a gigantic shield in orbit. That shield would work as an artificial bow shock, making up for a missing magnetic field. When that's all sorted, we'd bring in genetically engineered plants, suitable for growing on the moon's stony ground. We'd also drop some algae that would release oxygen into the air. That would be the start of life on the moon. Finally, after many decades of hard and costly work, we'd send the first human colony to settle down on the first man-made planet. The terraformed moon would get very warm from greenhouse effects. It would be mostly cloudy too, and with tides as high as 20 meters, surfers might want to make the trip. Living on the moon would be just like living in Florida, but with 1/6 of the Earth's gravity. The moon settlers would be able to jump as high as 3 meters off the ground, remaining in the air for 4 seconds. And if they were really fit and full of stamina, they'd be able to run across the moon's lake. This is because running on the water requires less muscle power if you do it in reduced gravity. Would you move to the moon to experience all that?
One day, Mars could look like this, allowing humans to comfortably live on the planet. All we'd need to do is to terraform it. But how? Well, we could nuke it. Would dropping nukes on Mars make it easier to live there? This is What If, and here's what would happen if we nuked Mars. Believe it or not, this is something scientists have considered for decades. Elon Musk of SpaceX seems to think that nuking Mars might be one of the best and quickest options to make it a place where humans could live. The idea is that we would explode thermonuclear bombs in the sky over the planet's two poles. This would heat up the ice caps and release carbon dioxide and water from the poles. Then the greenhouse effect would take place. It would heat up the whole planet, making the surface more habitable. So this all sounds super quick and easy. Why haven't we done this yet? It's because there's a high chance that nuking Mars might not work out the way we want it to. There are many things that could go wrong with this plan. The first problem is it's all just theory, and the theory could be wrong. That's because Mars has been losing its atmosphere for a long time. Earth's atmosphere is almost 100 times thicker than Mars's, and if we're going to live on Mars, it needs a thicker atmosphere. Some scientists think that we could release CO2 from the North and South poles, and this could make Mars's atmosphere more like Earth's. But a 2018 study published in Nature Astronomy found that even if the nukes are successful, it would only increase Mars's atmosphere to 7% of what Earth has. Even if we create more carbon dioxide in Mars's atmosphere, it still wouldn't be nearly enough to heat the planet. And the planet could seriously use more heat, since its current temperature averages around minus 63 degrees. And it would take decades for the red planet to warm up, even after it gained the extra CO2. So, in theory, this could delay humans from ever landing on Mars. Not only that, but this assumes that dropping thermonuclear bombs on the planet would go perfectly. Keep in mind, these are nukes. You know, the things that can destroy entire cities. In fact, the bombs we'd use on Mars would be 1,000 times stronger than the ones used in World War II. If a bomb exploded on the planet's surface instead of up in the atmosphere, some severe damage would occur. Not only would it completely destroy parts of the planet's surface, it would also cause even more radiation, another thing that would delay us from ever settling on Mars. It's also very likely that instead of warming Mars, a bomb could cause a nuclear winter. This could happen from the dust and particles in the atmosphere caused by nuclear explosions. They'd almost entirely block out the sun, causing Mars to cool down even more. So, nuking Mars probably isn't the best idea. And maybe we should get some humans on the planet in its natural state before we start trying to change it.
Okay, we've talked about settling on the moon, on Mars, and even Venus, but how about somewhere that's cold, dark, and smells like farts? Yeah, Uranus. Uranus. What would conditions be like on this ice giant? What kind of settlement would you need to build? And what dangers would you encounter on the stinkiest place in the solar system? This is What If, and here's what would happen if you lived on Uranus. Welcome to your new home on the 7th planet from the Sun. You'd now be a whopping 2.9 billion kilometers away from our solar system's energy source. Following in the footsteps of NASA's Voyager 2 probe, the journey to Uranus would take about 9.5 years, but now that you've made it, you'd catch a great view of this ice giant. What you'd find is a planet 4 times wider than the Earth, orbited by 27 known moons and 13 rings. Plus, it would be rotating east to west and tipped on its side. Well, it's about time you head down to the surface. Wait, where's the surface? As you descend, hold your nose. This place stinks. The gassy atmosphere of Uranus is primarily made up of hydrogen, helium, and methane. The higher altitudes would be the smelliest, thanks to the pungent, rotten egg smell of hydrogen sulfide. Going further down toward the planet's surface, you'd start to notice there isn't one. Uranus is smaller and compositionally different than the gas giants Jupiter and Saturn. It consists of slushy water, methane, and ammonia fluids above a small rocky center. Not that you'd be able to see very much. Uranus only receives about 0.27% as much sunlight as the Earth. So you'd be living in darkness. With the lack of sunlight and surface, you couldn't grow your own food there. Your ship would need to supply you with food. But you could source your water from the planet's water ice. You'd find conditions on the planet very cold and windy. Temperatures in some parts of the atmosphere could be as low as minus 225 degrees. That's colder than Neptune, the outermost planet in the solar system. Massive clouds of ammonia and methane ice crystals would swirl around you. Storms almost 2/3 the size of the United States would batter you with wind speeds up to 900 kilometers per hour. But it's too late to turn back now. You'd need to learn how to settle and survive in these conditions. Establishing yourself on the surface would be a definite no-go, and the strongest, most frigid winds would tear you apart in the lower altitudes. Your best bet would be a floating settlement up high in the clouds. But this wouldn't be your average blimp or airship settlement. Blimps only lift when inflated with a gas that's lighter than the surrounding atmosphere. On Earth, you'd use helium. On Uranus, there wouldn't be any lighter gas to use. That's due to the atmosphere made of molecular hydrogen and atomic helium. However, you could try something more theoretical, like a near vacuum ship. Instead of gas, this kind of ship would create a vacuum to lift. You'd simply remove gas or add it to allow the ship to go higher or lower. And it would be a clean technology. No fuel needed. You should get comfy because you'd never be able to leave your ship without your spacesuit. On Uranus, you couldn't breathe. And you couldn't survive a second in the unbelievably frigid temperatures. Just stay safe and enjoy the view. Okay, now that you've figured out how to survive, what would life on Uranus be like? Well, for starters, you'd find a slightly different sense of gravity than you're used to. But considering that Uranus is 15 times more massive than Earth, you'd be surprised by the difference. Contrary to what you might think, you wouldn't have to worry about being crushed. The surface gravity would be only 90% as strong as the Earth's. So if you weighed 75 kilograms on Earth, you'd now be a lighter 67 kilograms. Another thing you'd have to get used to is time. One Uranian day would be equal to about 17 hours on Earth. That wouldn't be so bad, but get ready for one incredibly long trip around the Sun. 1 year on Uranus would equal 84 Earth years. Yeah, you could die of old age before the year is over. You could even live an entire life in just one 42-year-long summer. or winter?
It's one of humanity's most ambitious undertakings, created to extend human exploration to the farthest reaches of our solar system.
The next step in space exploration isn't generations away. It's happening right now. And our destination? That mysterious and desolate world next door. Mars. Imagine starting life over on that tiny red dot, over 265 million kilometers away. What would happen if we built a city on Mars? Would you have to live underground? How many people would you live with? And what would the Martian economy look like? This is What If, and here's what would happen if we built a city on Mars. Since 1975, the only things from Earth making claims on Mars are robots and satellites. But now, Elon Musk and his company SpaceX are looking to change that story. Their goal? To create a city with a government, trade, and culture on Mars. This plan involves 1,000 spaceships and even more brave new recruits. By surviving in lower gravity with fewer people and only limited supplies, living on Mars might change how we could adapt to dwindling resources on Earth. But with so much depending on the early stages of planning and supply runs, could life on Mars be sustainable? Every great city starts small, whether you're talking about the little fishing town of Hong Kong or a hut village named Rome. So, if you want this Martian colony to grow into a thriving city, you're going to need more than a handful of people. According to the Bordeaux Institut National Polytechnique, you would need at least 110 settlers to start this adventure. The SpaceX plan starts with 2 spaceships carrying 100 people each. With this handful of explorers, your city would have just enough people to build more habitats and research stations without putting your resources in danger. If you run out of food at this stage, that's the end of the experiment. The biggest challenge this city faces is becoming sustainable without relying on regular shipments from Earth, which will only come every few years. You see, with the egg-shaped orbit of Mars, it takes 687 Earth days to make one Martian year. Supply runs would only launch when Earth and Mars align, which happens every 2 years, to cut down on travel time between our worlds. And after this nearly 8-month-long trip, there's still a chance of losing all those supplies when the rocket lands. Since the gravity on Mars is only 3/8 of the pull on Earth, landing safely on the surface of Mars would be dangerous. And that doesn't take into account the amount of dust flying in the air. After all, the dust on the Moon was bad enough, and it got into crew members' eyes and damaged systems on their spacecraft. But kicking up the dust on Mars might be even more deadly, since each grain is highly oxidized and electrically charged. But hey, you made it to Mars safely. Now, what are you going to eat? The chlorinated soils on Mars are toxic, and if you ingested them with your food, you might damage your thyroid gland. So that means farming is out. Outdoor farming, at least. Well, before you worry about eating, you'll need to set up protection from the harsh conditions on Mars. With an atmosphere made of 95% carbon dioxide, the air on Mars is toxic. And don't forget about the intense radiation on the surface. With more exposure to radiation and no breathable air, you won't be able to survive without a controlled environment. Thankfully, with the help of those rocks under your feet, you have all the protection you need.
Just 5 meters of the surface materials on Mars, called regolith, provides the same amount of shielding from radiation as Earth's atmosphere. This material would be processed into cement to create layered walls using robots and 3D printers. This material would be a protective shell, and underneath that shell, domed science facilities, living spaces, and all your home comforts. Connected by tubes, these domes would provide you shelter from the raging dust storms outside, which might last for months. Even with this technology, Elon Musk claims it could take up to 10 years to establish a colony. But it's during this time that your quaint Martian village would grow into the first human city beyond Earth. Since this world isn't being drilled or fracked, the power grid on Mars can be made sustainable right from the start. We would set up solar arrays for electricity and use natural gases like methane for engines. Our footprint on Mars could start low and stay that way, no matter how many people live there. And now you better figure out a way to feed all these people. The low gravity on Mars might decrease your muscle mass. To keep your body healthy, you'll need to provide more protein. You'll have to serve the equivalent of 110 cooked chicken breasts and 660 carrots every day. If one of these domes contained an indoor farm, you could raise the chickens you need to feed your city. And you would have the most nutrient-rich manure available. If you used this manure in the greenhouses, you'd have a way to fertilize your crops year-round. But how could you irrigate those crops? How would you get water? Scientists still debate whether liquid water exists below the ice caps on Mars, but if it does exist, that freshwater source could be filtered for the colonists to use for irrigation. With less gravity on Mars pulling water down into the ground, you would need less water to keep your plants alive than you would on Earth, since it would stay closer to the surface. And with supplies being transported only every 2 years, having spring water available on Mars would change how the city would operate. It would create a government infrastructure to distribute and oversee the water supply and employ scientists to manage the filtration needs. Now, the city has an infrastructure in place and jobs to fill, so how would you value your time in terms of cash? How could you pay for products or services? Cash weighs too much to travel with in outer space, and credit cards would require Wi-Fi services communicating back to Earth. With a 14-minute gap in communications between Mars and Earth, you're gonna need something more locally based. Well, you might have to use a cryptocurrency known as Mars Coin, but you would have need to have bought it with your Earth money before you boarded the spaceship. While Mars Coin would only be available to Martians, this money would help build the government, increase trade, and create a standard of living. With society on Mars still new, maybe you could trade your services or learn to barter goods instead of relying on this cash system. If we do things right, life on Mars might be the model for future civilizations, free from the constraints of the culture built on Earth. Or it could be like every sci-fi movie ever made.
Jupiter may be the biggest planet in the solar system, but its days are numbered. Because today, we're using Earth's biggest, baddest bombs to blow the gas giant into oblivion. How many nukes would you need to do the job? What obstacles would these rocket-bound bombs encounter on the way? And would one nuclear explosion ignite the entire planet? This is What If, and here's what would happen if we nuked Jupiter. Nuclear weapons are so powerful that even the low-yield versions, like those dropped on Japan by the United States in World War II, have the explosive equivalent of 15 to 20 kilotons of dynamite each. What makes them so volatile is that they harness the intense energy-releasing power of nuclear fission or fusion. These are the same processes that happen in our very own sun. So be careful when moving these things out to Jupiter. One false move and you could be incinerated by a fireball as hot as the center of the sun. In order to blow Jupiter to bits, one single bomb wouldn't necessarily be up for the task. Good thing for this scenario that there are a lot of nuclear weapons on Earth. Maybe the safest plan would be getting them all off our planet anyway. Given the top-secret nature of military activities, it's hard to know the exact number, but estimates put the global arsenal at about 12,700, with the United States and Russia battling for top spot with 5,500 to 6,000 weapons each. Okay, there's no use in delaying. Let's get these rockets off Earth as fast as possible. The distance between Earth and Jupiter fluctuates from about 590 million to 970 million kilometers. In the past, missions like the Galileo space probe took nearly 5 years to make the journey to the gas giant. But our rockets wouldn't take this long. Galileo had to be slow enough to enter Jupiter's orbit. We just need to hit the planet head-on, so you'd only be looking at about 550 to 650 days to get the job done. You shouldn't be too reckless and speedy, though. You don't want to nuke something else by accident. Now, bypassing the Moon and Mars would be easy enough, but getting safely through the asteroid belt would be like navigating a minefield. There are millions of asteroids riddled between Mars and Jupiter, and while the average distance between them is a not-so-worrisome 966,000 kilometers, sometimes it can still get a little cramped in there. And Jupiter is partly to blame for this. The planet's massive gravitational influence causes many of these to group into clusters known as families. Carelessly navigate through one, like the Flora family, and you'd better hope none of our rockets would collide with any of its 400 asteroids. For the best chance of success, you should aim to transport your rockets through the Kirkwood gaps. These are nearly asteroid-free regions in the belt, because you'd hate to see all of our planet's nukes detonate themselves in a blinding chain reaction before reaching our target. As the first of our bombs exploded on Jupiter, you'd see bright flashes back here on Earth. Just like when the Shoemaker-Levy 9 comet slammed into Jupiter in 1994. But that only released 5% as much energy as the Tsar Bomba, the largest bomb ever created. So, with thousands of our nuclear bombs, Jupiter's days would have to be numbered, right? Well, not exactly. Even though our nukes could produce an explosion hotter than the sun, this wouldn't cause all the hydrogen on Jupiter to ignite. It just isn't dense enough to sustain nuclear fusion. And even if every bomb was detonated, Jupiter wouldn't blow up completely either. In order to do that, we'd need to unleash as much energy as the sun releases over 160 years, all at once. And for that highly energetic result, about 1 billion nukes would be required. Somewhat more than the 12,700 in our arsenal. To build that many bombs, you'd need a combined mass of material that would almost be twice that of the largest moon in the solar system, Jupiter's Ganymede. No small feat, since it's bigger than Pluto and Mercury.
Would you ever want to buy your own planet? Even if it was just the size of a house? It could be the perfect vacation spot. Unbeatable privacy and breathtaking views. What more could you ask for? Well, before you go signing the mortgage, there are a few things you'd want to consider. Like, would a tiny planet have air for you to breathe? Could you grow food there? And would there be enough gravity to keep you on the surface? This is What If, and here's what would happen if you lived on a tiny planet.
To figure out what life would be like on a tiny house-sized planet, you'd have to find one first. But the smallest planet we've discovered so far, Kepler 37b, is still about the size of our moon. So maybe you're better off looking at an asteroid instead. They're not technically planets, but they can be as small as 10 meters wide, so they fit the physical properties you're looking for. But there are a lot of asteroids out there, so how do you pick the best one to live on?
The main asteroid belt in our solar system orbits the Sun roughly between Mars and Jupiter. It contains 3 different types of asteroids: stony, carbonaceous, and metallic. The kind that you'd be looking for is carbonaceous, because those asteroids are usually made up of 10% water, which can be broken down to oxygen for breathing. How about this one? It's about 10 meters wide, just the size you were looking for. It almost seems a little too convenient, doesn't it? Well, that convenience wouldn't last long. Once you'd landed on your new tiny planet, you'd realize that the conditions are a lot different from what you're used to. For starters, your feet would feel a lot heavier than your head. That's because your tiny planet's gravitational force would be so weak that you would also experience the feeling of other gravitational forces pulling you upward. The other forces wouldn't be strong enough to pull you off the planet, but they would result in you feeling a mild stretching sensation as they compete with the gravity of your planet. Speaking of gravity, you'd also have to be careful how quickly you move around on this planet, because if you move too fast, you could escape its gravitational pull. Every planet has something called an escape velocity, which refers to the minimum speed
An object must have to escape its gravitational field. On a planet this size, the escape velocity would be 5 meters per second. That means you could technically leave the planet by getting a running start and leaping off a ramp. Then, you'd be floating off into space. Bye-bye. But assuming you're not going to try that, you're going to be here for a while, and you should probably start figuring out how to survive. The first thing to worry about is, where are you getting your food? Well, I hope you like veggies, because any meat is pretty much out of the question. Not only would you have to bring some livestock along with you through space successfully, you'd also have to find enough room to keep them and grow food for them. And you don't have much room to begin with. For the vegetarian option, you could bring something similar to what NASA uses on the International Space Station. It's called the Vegetable Production System, and it's a garden that's about the size of a piece of carry-on luggage that can hold 6 plants. It's specifically designed to grow plants and vegetables in microgravity conditions. No, you wouldn't have the most exciting menu on your rocky retreat, but at least it would keep you alive. Now, before you go trying to figure out anything else, there's something you might want to see. A 2019 study published in the Astrophysical Journal states that any planet smaller than 2.7% of Earth's mass would lose its atmosphere and any liquid water it might have due to a lack of gravitational force. Well, even 2.7% of Earth's mass is still double the mass of the Moon, so your tiny planet would be without those 2 major components for sustaining life. If your planet can't hold an atmosphere, then you wouldn't be able to breathe, and you wouldn't have protection from the harmful radiation of space.
Mars didn't always look like this. it may once have been covered in oceans. But what if we brought all the Martian water back and transformed the red planet into one that's half blue? What would Mars look like if it was 50% land and 50% water? Where would we even find enough water to fill Martian oceans? And why might we have no choice but to nuke the red planet? This is What If, and here's what would happen if Mars was half land and half water. Long ago, Mars could have been covered by a massive ocean, and there may have been rivers, streams, and lakes spreading out across the planet too. It might be that billions of years ago, Earth and Mars had similar climates. Except the Martian ocean covered only 20% of the planet compared to Earth's 71%. And the surface temperature was a bit cooler. All of that thanks to an atmosphere that didn't stick around long enough. 4 billion years ago, Mars lost its protective magnetic field. And the solar winds started to carry all of its atmosphere off into space. A few 100 million years later, Mars changed from a warm, wet world to what we know it as today. Cold and dry. Only 18% of its ocean remains, trapped in frozen polar ice caps. So if you wanted to turn Mars into a half-land, half-ocean kind of planet, you'd need to add a whole lot of water. Unlike Mars, most of Earth is covered with oceans. So, what do you say we donate some of that water to our red neighbor? Well, let me tell you, that's a very, very bad idea. To make Martian oceans as deep as Earth's, you'd need to ship out about 20% of our ocean water. And this would suck for our marine life. Yeah, leave the Earth's oceans where they belong. Besides, there are a few other places in the solar system where you could find water, like Saturn's moon, Enceladus, and Jupiter's moon, Europa. They might have twice as much water as Earth, but to transport some of that precious H2O, you'd need to move massive ice blocks through space. This would be difficult to pull off, to say the least. You'd need rockets capable of transporting huge amounts of weight, and you'd need money. Yeah, a lot of it. 'Cause the price could be as high as $1,500 per kilogram. And considering how much water you'd require, well, the final price tag for this operation would be well into the trillions. Yeah, expensive, I know, but there might be another way of bringing Martian water back. And you'll love this one because it involves nukes. Yeah, you heard me right. You're about to nuke the red planet. And yes, this would give it some water. How? Well, all that energy would release frozen Martian carbon dioxide. This would cause temperatures to climb and thaw out the poles. It would be kind of like causing controlled climate change. Only you'd need to detonate around 3,500 nuclear bombs every day. And this would mean shipping twice as many bombs daily as the United States currently has in its entire arsenal. That's an enormous amount of radioactive material to release. And it wouldn't exactly make Mars habitable. Plus, you'd still need a lot more water to cover half the planet in oceans. Okay, it seems like nuking everything in sight isn't the best idea. Maybe you should take a little planetary history lesson instead. About 4 billion years ago, during the late bombardment period, a non-stop barrage of asteroids collided with Mars. This created enough water to eventually make an ocean 300 meters deep. So all you'd need to do is recreate this event today. You'd have to redirect at least 1 million comets and meteors so that they'd end up on a collision course with Mars. As the comets crashed into Mars, they'd burn up and release water vapor. Rinse and repeat until you get enough water to cover half the red planet. But where would this water go? Well, looking at Mars's topography, you'd find that all this new water would settle mostly above its equator. Mars would have new land masses that would look like continents. There would even be mountains sticking up on some parts of the planet. Olympus Mons, the tallest volcano in the solar system, would now tower high out of Mars's new northern ocean. But just because you were able to bring enough water to cover half the planet, that wouldn't mean it would last. Because of Mars's low atmospheric pressure, all this water would easily boil away. Well, wait, how would it boil away if water's boiling point is 100 degrees Celsius? Aha, well, that's the boiling point on Earth. On Mars, the water would start to boil at 0 degrees Celsius. That's frustrating, especially after all the work you put in bringing all this water to Mars. You'd have to hope that this water vapor would work as a greenhouse gas. If it could trap enough heat in the Martian atmosphere and turn Mars into a lush, terraformed world, maybe then you'd be lucky enough to be the only Earthling ever to go for a swim on another planet. Humanity's nuclear arsenal is capable of destroying all life on Earth, over and over and over. Maybe it's time we dumped it far away. Now, we might want to inhabit other planets in the future, so how about our closest star? How many nukes could we throw at the sun? What would be the price tag for this mission? And could we accidentally destroy our only source of daylight? This is What If, and here's what would happen if we nuked the sun. The sun is mainly made of hydrogen and helium. The temperatures and pressures at its center are extremely high. So high that the hydrogen atoms fuse together and become helium. That process releases enormous amounts of energy that powers the sun. It's known as fusion. And you know what else uses fusion to power up? Yeah, that's right. Most modern nuclear weapons get their destructive energy from fusing hydrogen isotopes. This is why they're often called hydrogen bombs or fusion bombs. Around 5 billion years from now, the sun will run out of hydrogen and die. A dead sun is terrible news for Earth because we will die along with the star. Now, if humans managed to stick around for that long, we would be scrambling for ways to keep the sun fueled and running. And if we were also still interested in getting rid of our destructive hydrogen fusion bombs, could we nuke the sun and power it back to life? Well, first things first, we would need to gather each and every single nuke on the planet. This wouldn't be easy since the 9 countries that are known to possess nukes are extremely suspicious of each other. But if the other option is the guaranteed death of our only sun, they could be willing to give up their weapons of mass destruction for the cause.
Take my gun from me.
How big is humanity's arsenal, you might ask? Well, at least 13,000 nuclear bombs big. Each of them with the explosive power of at least 100 kilotons of dynamite. The United States alone is estimated to have 650 bombs that are 60 times more powerful than the nuclear bomb dropped on Nagasaki during World War II. If you were overseeing this explosive operation, you would need to be extremely careful. After all, you definitely wouldn't want to have a surprise detonation. If every one of these fusion bombs went off, the explosion would lead to so much debris being injected into the atmosphere that it would trigger a nuclear winter. That's because sunlight would be unable to reach the Earth's surface. Cue the worldwide below freezing temperatures, ecosystems collapsing, and nuclear fallout. This accident would devastate all living beings, humans and animals alike. In trying to save the sun, humanity could block itself from all of its warm rays. Ironic, isn't it? So yeah, you'd need to handle with care. You'd also have to sharpen your fundraising skills. If a modern nuke has a mass close to the one dropped on Nagasaki, sending it to space would cost around $170 billion. And that's just for one bomb out of the 13,000. It's fair to say the whole world economy would need to bend and break in order to subsidize the survival of the sun. And humanity. Even if you did come up with the cash, there are far hotter challenges ahead. Like, how do you build a spaceship that doesn't melt as it approaches the sun? The closest a spacecraft has come to our star is 8.5 million kilometers. Even at that distance, it still had to endure temperatures of 1,377 degrees Celsius. Only thanks to a thermal shield made up of carbon composite material was it able to withstand the scorching heat. However we send our hydrogen bombs into space, it will have to incorporate a much improved version of this protection system. So add that to the bill. And there would still be a mountain of remaining technical obstacles, like finding the safest location to launch the nukes into space, or developing the technology that will allow us to monitor and control them from such a massive distance. But let's say you manage to do it. All our nukes are in orbit and within launching distance to the sun. This is it. You send the order to fire all the hydrogen bombs into our hydrogen-fueled star. Now, you wait to see how it begins to recharge. Just a little longer. And nothing seems to happen. The anchor of our solar system continues to die. But how? Well, as colossal as the power of our 13,000 nukes might seem, this punch is nothing compared to what the sun is packing. Right now, our star emits over 70 million times more energy per second than all of our nuclear weapons combined. Even if it were running out of hydrogen to fuse into helium, throwing our hydrogen bombs at it to feed it would be like throwing a box of matches into a forest fire. You'd barely make a dent in the blaze. Yeah, that's a bummer, but at least you didn't destroy what little remains of our decaying sun. If that was your intent, you'd need something with a lot more firepower. Meet the antimatter bomb. When the Big Bang created the universe, it did so with an equal amount of matter and antimatter. Matter is what you, the Earth, the Sun, and most things are made of. Antimatter, on the other hand, is composed of subatomic particles with properties opposite to those of normal matter. Put a little simpler, it's the inverse of matter. When a particle of matter collides with an antiparticle of antimatter, they annihilate each other in a flash of energy. If enough of those two camps came in contact with each other, it would lead to a massive explosion, also known as an antimatter bomb. But here's the catch. antimatter is incredibly rare. If you pooled together all the antimatter on the planet, you'd end up with only around 20 nanograms. A single nanogram is only 1/1000th of a gram. That is so little that even if it were combined with matter, you wouldn't even have enough energy to boil a cup of tea. Now, you could produce more antimatter, but that would cost you at least $2.7 quadrillion for just 1 gram. And remember, we're here to save the sun, not destroy it.
If you could, would you live on the moon? Not as one of the courageous early settlers, but as a citizen of a fully functioning moon city. What would these cities be built of? How different would your everyday life be? And why would these cities be important? This is What If, and here's what would happen if we built cities on the moon. In 2005, a design called the Shackleton Dome caused a thrill in the aerospace industry. This 40-kilometer in diameter and 1,524-meter high glass dome would arch over the Shackleton crater on the moon, housing the first moon city. How viable was this design? Domes are the strongest structural objects and the most efficient shape to hold air pressure, so building domes to protect people from the hazards of space is a good idea. But smaller, interconnected domes based off the Shackleton Dome would be quicker and cheaper to build. They would be made of glass and titanium and anchored to bedrock, allowing moon cities to thrive inside. The cities themselves would look ultra-modern, and not because of any stylistic taste, but because aluminum and silicon, the main components of glass, are the elements found in anorthite. Anorthite is a mineral found on the moon and would be an important local resource for construction. With so much of it in the surrounding landscape, it would be foolish not to use it liberally. Another popular construction material used in this futuristic city would be a concrete-like geopolymer created from 2 additional readily available materials: moon dirt and your pee. Yes, your moon house would be made from urine. What would life be like in these futuristic cities? Well, you wouldn't experience normal days and nights anymore. 1 lunar day is 29 Earth days, which means there are 2 weeks of darkness and 2 weeks of light. But because cities would be built around the moon's poles, you would only have to experience 4 consecutive Earth days of darkness at a time. Your diet would also change. Due to the finite resources and limited space, moon cities wouldn't raise animals for food production, so your diet would be mainly plant-based. You might have the option of eating fish, but any other meat would have to come frozen from Earth, so that wouldn't be very practical. The moon's major industry would be mining and exporting helium-3, a renewable source of energy and other materials. You'd probably have a career as a scientist, engineer, or miner. As the Earth continues to use up its precious resources, the demand for helium-3 would grow. Helium-3 is an efficient fuel source in fusion reactors and sells for roughly $40,000 US per ounce. Just 25 tons of it would power the entire United States for 1 year. While rare on Earth, it's found in abundance on the moon. This export, combined with space exploration and moon tourism, would bring a lot of wealth to moon cities and help repay the expensive price tag of initial settlement and construction. NASA estimates it would take $10 billion to build a settlement on the moon, with an extra $2 billion per year in ongoing costs. Building cities on the moon would have to be an international combination of corporate and government partnerships. Currently, treaties prevent any one country from owning the moon. If a single country built a metropolis on the moon, it could be seen as a violation of those treaties. With no single country or nation, the citizens of moon cities would probably try and form their own self-governing nation once they became self-sufficient. While domed moon centers sound like science fiction, they are realistically in our distant future. Settling the moon would open up opportunities for science, engineering, new ways of thinking, and further space exploration. It would be a necessity to create a viable space base to branch out to other parts of our universe. But
It's been 100 Earth years since you settled on Mars. You've been through pain, loneliness, and a lot of hard work. And now, Mars is the new promised land everyone dreams of. But how did you get there? How would you find clean water and air on Mars? What would you have to do to make Mars self-sufficient? And how long before everyone can afford to travel to Mars? This is What If, and here's what would happen if you spent 100 years on Mars. It all started when SpaceX founder Elon Musk imagined that 1 million people could be living on Mars within 100 years.
I reinvented electric cars and I'm sending people to Mars in a rocket ship.
Well, Mars has been a worthy contender for Planet B since 1960, when uncrewed missions began. It's got the same day rhythm as Earth and carbon dioxide for plants to do photosynthesis. Mars has 38% of Earth's gravity and 1% of its air density. It gets 44% as much sunlight as Earth. These wouldn't be the conditions you're used to, but it would be a start. So you packed up and got yourself a job on the first base on Mars. And not just any job. You would be the first person to set foot on the Red Planet. 100 years in, what milestones of civilization would you see? To go on this dangerous interplanetary voyage, you'd need to be an astronaut. You'd spend years in training before you could even board the shuttle, but you made it. Yes! And now, it would be you versus Mars. You'd land in the surroundings of the Jezero crater. That's where the Perseverance rover touched down in 2021 to check out the territory before your arrival. You'd be doing some research and reporting back to Earth. The connection wouldn't be great. You'd have to wait up to 22 minutes for communication signals to get to Earth.
Eventually, you'd witness the first cargo ships arriving with supplies. A few years after your arrival, the first batch of settlers would appear. Everything they'd need would be ferried from Earth, and it would cost hundreds of millions of dollars to feed each person. So you'd need to start thinking about how to make the settlement self-sufficient. First order of business, water. The settlers would start the mining of water ice near the base. You would see the first human base set up on Mars. It would be named Mars Base Alpha,
Just like Elon Musk wanted. You and 170 other astronauts would live there. Robots would be taking care of the initial prospecting and construction. It would no longer take 20 minutes to receive communication signals from Earth. That's because your settlement would set up 2 constellations of Starlink satellites orbiting Mars. More people would arrive from Earth, another base would be underway, and finally, the very first child would be born on Mars. But could this Martian child ever visit Earth? how would their bones and organs survive in Earth's gravity? Mars Base Alpha would become a full-fledged settlement. You would see many more firsts. The first school, the first cultured meat farm, and even the first luxury hotel. Public transport would connect Base Alpha to mining sites. Every few years, ships would arrive, each carrying 100 passengers. The settlement would begin building its first dome city. It would be a 1.6-kilometer wide impact crater covered by a transparent radiation filtering dome. It would need Earth-like pressure and temperatures so the settlers could finally take off their spacesuits. At this point, the population of Mars would reach 200,000. With advanced medical technology, your life expectancy would increase. You would finally be able to visit your friends back on Earth. It wouldn't be so easy for those born on Mars. They would need to use exoskeletons to survive Earth's heavier gravity. Wealthy people from Earth would come to Mars on vacation. An artificial magnetic field generator would permanently protect the Martian atmosphere from space radiation. Mars would now have 5 dome cities. The largest among them, Mars City, would be home to 60,000 people. Soon, the first elected city council would take office, and the first university would open. 1 million people would permanently live on Mars. You and your fellow settlers would be on pace to terraform the planet. You would release controlled amounts of greenhouse gases to thicken the atmosphere and cause the temperature to increase. You'd accelerate the process by establishing fish farms and releasing cyanobacteria that would start photosynthesis. There would be a rising tide for independence in Martian cities. Martians might not be too keen on staying controlled by the Earthlings. After all, they'd have 100 years of history to be proud of. Mars Base Alpha would become a national heritage site, and hyperloops and suborbital shuttles would connect major Martian cities. Eventually, the dream of terraforming would come true. Fresh water would flow in the once lifeless Martian surface, and settlers would finally be able to breathe in lungs full of fresh Martian air. If you were born and raised on Mars, your body would look very different. Mars might be the best candidate for humanity's future space settlement, but as far as gravity, breathable atmosphere, and liquid water go, it ain't the kind of place you could survive. At least not in your current state. If you tried to walk on the red planet without a spacesuit, you'd suffocate, swell, and die of extreme radiation poisoning within minutes. Yeah, that wouldn't be pretty. To survive Mars's harsh environment, you'd have to be taller and leaner. Martian gravity is only about 38% of Earth's gravitational pull. That means you wouldn't need much muscle power to walk around. You'd lose bone and muscle density, but that's okay. Your taller frame would use less energy, and that's good news because food on Mars would be pretty scarce. Plus, being taller would help you see further. Speaking of sight, your eyes wouldn't be the same. Mars is known for its dust storms, and it's not as sunny here as it is on Earth. Your eyes would have to adapt. You'd see better in low light, and your tears would be sticky to protect you from all the dust and debris. Now, Mars barely has an atmosphere, and that means 2 things. First, your lungs would become super lungs, capable of extracting trace elements of oxygen from the Martian atmosphere. And second, your skin would be dark brown to protect you from the harmful solar radiation. Yeah, without a dense atmosphere, Mars gets bathed in radiation. It also gets extremely cold on the red planet. Thanks to almost zero atmosphere, the temperature here ranges from a comfortable 20 degrees Celsius to a freezing cold minus 153 degrees Celsius. But your dark skin would absorb more heat to help you survive when it gets chilly. What if you were born on a much hotter planet than Mars? Well, welcome to Venus. It has a dense atmosphere which traps the sun's heat and turns the planet into a furnace. It's so hot on Venus that if you walked outside without a spacesuit, you'd instantly be incinerated. You'd also get crushed under the extreme atmospheric pressure, 92 times higher than Earth's. Evolving to live on this hellish world would mean having a short and sturdy body with thick silver skin. Yeah, your skin would have to reflect the intense heat and radiation. It would also need to be able to neutralize sulfuric acid. Yeah, that's right. Venus has a thick carbon dioxide atmosphere with clouds made of sulfuric acid droplets. So you'd need to be ready to withstand the Venusian acid rain. And your shorter, more compact body would provide the necessary support to withstand the extreme atmospheric pressure. But you still couldn't breathe the toxic Venusian atmosphere. You'd need to rely on oxygen tanks. You'd also never have an active lifestyle on Venus because you'd need to conserve your energy and whatever oxygen you could get. You'd pretty much be stuck in your living quarters the entire time. Yeah, living on Venus would be difficult, even with an extremely sturdy skeleton. So let's try another planet, like Mercury. Mercury is even closer to the Sun than Venus. On Venus, you'd have to worry about scorching heat. On Mars, you'd have to adapt to freezing temperatures. Well, on Mercury, you'd be dealing with both. Just like Mars, Mercury has almost no atmosphere, so temperatures on this tiny planet range from a blazing 427 degrees Celsius during the day to a frigid minus 179 degrees Celsius at night. And one night here lasts almost 3 Earth months. You'd need a thermal insulation layer under your skin to stand a chance on this planet. It'd make you look metallic, just like on Venus, but it would help reflect the incredible heat and then retain that heat once the temperature dropped. Your body would evolve to be sturdy and stocky, with a layer of fat helping to keep you warm during cold nights. But your limbs would be longer and more flexible so you could move around easily. You wouldn't have much muscle because Mercury's gravity is only about 38% of Earth's gravity. You'd develop cells resistant to radiation. That's because Mercury is 3 times closer to the Sun than Earth, and it has no atmosphere to protect you. And breathing on Mercury would be impossible. Maybe you'd have smaller lungs capable of storing oxygen. You might even evolve to have a special organ that could produce oxygen from the minerals you ingest. Kind of like how plants make oxygen through photosynthesis. Life on Mercury would be pretty miserable and uneventful, but wait till you see what life could be like on Jupiter. Okay, here's the thing about Jupiter. It's not made to live on. First, it doesn't even have a surface for you to walk on. You'd be gliding through clouds of hydrogen and helium. You'd lose bone density, but your muscles would be strong. And you'd have to be short and compact to withstand the intense pressure of the gas giant. Your dark skin would give you some level of protection against Jupiter's radiation, and you'd be full of gas. Yeah, in order to be able to fly in Jupiter's thick atmosphere, your body would need to have lighter-than-air gases. Your biggest problem would be breathing. You could adapt to the extreme radiation levels and high atmospheric pressure, but Jupiter has 0 oxygen in its atmosphere, so unless you could evolve to breathe hydrogen or helium, you wouldn't survive long on this planet. And it's the same story on Saturn. Only there, you might evolve to have specialized organs that could synthesize breathable oxygen from water vapor or ammonia. So, more points for Saturn. On Uranus, you'd look like a short blue alien. That blue pigmentation could give you some protection against cosmic radiation. Your skin would need to be very thick and have the ability to retain heat well. Uranus is cold. It's one of the coldest planets in the solar system, reaching freezing temperatures of minus 224 degrees Celsius. There's no way you could breathe on Uranus because, just like on Jupiter, there's no oxygen on this ice giant. And no solid surface either. Uranus is like a giant cloud of farts. Yeah, thanks to hydrogen sulfide and its clouds, this planet reeks like rotten eggs. So maybe it's best you don't breathe in all that stink. Being born on Neptune would be exactly like being born on Uranus, minus the fart smell. Neptune is slightly warmer than Uranus, but that wouldn't be enough to make this ice giant habitable. Even with a body designed for this planet, you couldn't survive here.
Not only are Earth and Venus about the same size, they both have identical interiors with partially liquid cores, mantles, and crusts. Yet Venus happens to be the most hostile terrestrial planet in the solar system. But what if I told you that you could explore this hot planet without ever setting foot on it? This is What If. And here's what would happen if we built cloud cities on Venus. Venus isn't a place you'd want to land on. Thanks to its dense atmosphere and turtle-like rotation, the surface temperature of Venus stays at 462 degrees. The planet's atmospheric pressure is 92 times greater than Earth's. Because of such high pressure, anything entering the atmosphere of Venus gets immediately crushed before it reaches the planet's volcanic surface. With such extreme atmospheric conditions, it's too dangerous to attempt a manned landing on Venus, but we wouldn't need to go down there. Above the dense layer of clouds, Venus isn't that bad. The atmospheric pressure is similar to Earth's. The gravity is slightly lower, and the temperature reaches 75 degrees. Although that's a little hot, it's still workable. Now, how would we get there? Well, we'd need to start small. According to NASA's plan for exploring Venus, we'd send 2 spaceships to our destination. Venus is the closest planet to Earth. That's why it would only take 100 days for the craft to arrive there. One of the ships would be run by robots. It would carry a special airship that would eject into the atmosphere upon arrival. This airship would start to inflate itself with helium. And since helium is lighter than air, the airship would float, orbiting about 52 kilometers above the planet. The second spaceship would have a crew of 2 people. It would link up with the airship orbiting Venus. The crew would have 30 days to make all the environmental assessments. After that, they'd detach from the airship and start making their way back to Earth. The return trip would take about 300 days due to the Sun's strong gravitational pull. But even with that, the complete mission wouldn't take longer than 450 days. After analyzing the information from the first mission, we'd begin to plan our next trip to Venus. But this time, we'd stay there longer. The next crew would have a year to study the planet and its atmosphere. One of the things they'd be looking for on Venus would be life. Scientists think that because microbes on Earth can thrive in acidic conditions surrounded by sulfur, there could be life found in the Venusian atmosphere. After the end of the second mission, we would start preparing to stay on Venus permanently. We would begin building cloud cities, where future generations of humans would live and hopefully continue to explore space and the origins of life in it. They might even solve the pressure problem. From there, they would terraform the planet and settle down on the once hostile Venusian surface. Is alien life really out there? Humanity has wondered about it for decades. And according to scientists, it might finally be a reality. Astronomers have discovered there could be life on Venus. Does this mean we finally meet aliens? Could this help us discover other aliens? And what does this discovery mean for us? This is What If, and here's what would happen if there's life on Venus. Venus might not be as alien as you think. The planet is roughly the same size as Earth, and its gravity is 91% of our planet's. We always talk about Mars being a potential home for humans, but we shouldn't count out Venus either. And if there is life on the planet, could this speed up our process of making it our new home? First, let's look into why exactly scientists think there might be life on Venus. It all has to do with phosphine. This is a colorless, flammable, and explosive gas that's also pretty stinky. It smells like a mix of garlic and decaying fish. Ugh. This gas can be found on Earth, and it's dangerous to everything that uses oxygen to survive. It was used as a chemical weapon during World War I and is a byproduct of cooking methamphetamine. Yeah, this gas is not very pleasant, and it can be extremely deadly, but now astronomers have found that phosphine might be in Venus's atmosphere. At first glance, this might seem like a terrible thing because this gas kills anything that breathes oxygen. But that doesn't mean that life can't exist. Just because something doesn't require oxygen doesn't mean it's completely lifeless. Inside Venus's clouds of phosphine, there could be anaerobic bacteria. These are organisms that don't require oxygen to survive. They could be living on Venus, producing this phosphine gas. Keep in mind that all of this is not fully verified yet, but astronomers have been keeping an eye on Venus for nearly all of 2020, and this is what they think they've discovered. So, if this type of alien life really did exist on Venus, what would it mean for us humans? Well, when you first hear about alien life, you probably think about Martians with big heads and us being able to shake their hands, but that wouldn't be possible with these life forms on Venus. As it stands right now, we wouldn't be able to see any of the life on Venus with our naked eye. It's all bacteria and microbes. And with all that potential phosphine on the planet, it makes visiting Venus more dangerous for humans than ever. So, will we be meeting this life form anytime soon? Probably not. Is this discovery still incredibly exciting? Absolutely. Yay! And sure, it's discouraging that we haven't found Martians yet, but try not to be too disappointed. When discovering potential alien life, we should remember to expand our ideas about what exactly these alien life forms could be. They don't necessarily have to be something with 2 or 4 legs that humans are able to interact with. The possibilities for potential alien life are endless. Things we can't even imagine yet. And who knows what this current life form could turn into? It may start small, but in millions of years, we might see Venus bloom into a planet full of organic life. And life on Venus might not be limited to organisms living in phosphine gas either. Experts think that due to all the extreme climates on the planet, life could form almost anywhere. And that goes for the rest of the solar system too. With scientists discovering potential life on Venus, who knows what else is out there? Researchers will just have to keep searching to find out.
When it comes to planets in our solar system's habitable zone, one world is too close to the sun, another is too far, and Earth is just right. But maybe things would be different if Venus and Mars simply swapped orbits. What makes these planets impossible to live on right now? What changes would they undergo when they traded places? And why would you need Jupiter to give these planets a chance at supporting life? This is What If, and here's what would happen if Venus and Mars swapped orbits. Our solar system's habitable zone, otherwise known as the Goldilocks zone, is the distance from a star where liquid water could exist on the surface of a planet. As long as conditions aren't too hot or too cold, life could be possible, just like on Earth. But simply occupying prime real estate in the habitable zone isn't a guarantee that a rocky planet is actually habitable. Both Venus and Mars orbit within this region too, and yet no life. Despite being of a similar size and with roughly the same surface gravity as Earth, Venus is too hot to hold liquid water. And dense. Its atmosphere is 90 times denser than our own, and the surface temperature is a scorching 462 degrees Celsius. On the other end of the Goldilocks zone, Mars is also quite Earth-like, except way colder, drier, and dustier. Its average surface temperature is minus 46 degrees Celsius, and it has an atmosphere about 1% as thick as Earth's. So, if we swapped things around, would Venus and Mars transform themselves into perfectly livable planets? Bringing the red planet into Venus's orbit would put it at a distance of approximately 108 million kilometers from the Sun. This would bring it halfway closer to the Sun than it was before. Being so much closer, Mars would get a significant boost in the amount of sunlight it receives, and that alone can make the surface temperature climb to a balmy 32 degrees Celsius, just like the Earth's tropics. But without a thick atmosphere or oceans, all this new heat wouldn't stay on the planet. Just like in Earth's deserts, Mars would see extreme temperature differences between day and night. The thin Martian atmosphere would make it difficult for water to stay liquid. With such a low surface pressure, water would boil at a lower temperature. Evaporation would happen much quicker. Looks like if you want to see life flourish on Mars, you'd have to take a slightly more hands-on approach. But first, let's check out how Venus is doing in its new neck of the woods. You'd now find Venus located 228 million kilometers away from the Sun. That's twice as far as it used to be. And naturally, you'd think, surely this scorching planet would be starting to cool down. Well, as it turns out, the planet's high surface temperatures have a lot more to do with its thick atmosphere than its overall closeness to the Sun. Venus has a very high albedo, which means that it reflects about 75% of the incoming sunlight. So it could be that the planet's temperature remains more or less just as hot as before. Even as the upper parts of the atmosphere slowly cool enough for the albedo effect to decrease, that would mean that Venus could now absorb a larger amount of incoming sunlight, so that temperature wouldn't start to drop all that much. Another setback on the road to becoming a life-supporting planet would be that Venus's atmosphere is mostly comprised of carbon dioxide, with small amounts of nitrogen and clouds of sulfuric acid. What you still wouldn't find nearly enough of is water. The concentration of water in Venus's atmosphere is 100 times too low for even the most resilient organisms back on Earth to survive. But since you went through all the effort of bringing both planets from one end of the habitable zone to the other, why not take things a little further? You could try terraforming the planets to make them a little more livable. One way you could increase the surface pressure of Mars would be to try releasing all the carbon dioxide found in its soil and minerals. The only problem here is that the red planet would need to reach temperatures above 300 degrees Celsius. And despite this new location so close to the Sun, Mars would never get this hot. Besides, if you could release all of that precious greenhouse gas, it would only amount to an atmospheric pressure of about 10 to 14% of Earth's. There simply isn't enough carbon dioxide on the red planet. Even if you had been successful with that effort, you'd still be unable to breathe on Mars. One option for dealing with this would involve bringing special microorganisms to the planet that could convert the hostile Martian atmosphere into breathable air. This would be similar to what Earth was like 2.5 billion years ago. Back then, cyanobacteria converted our methane and ammonia-rich atmosphere into the oxygen-rich one you enjoy today. But ultimately, this would be a big waste of time and resources. You'd find that with Mars's weak magnetic field, it wouldn't be able to hold on to any atmosphere you could create. That would be thanks to the power of solar winds that would constantly strip away whatever atmosphere you'd managed to generate. And sitting in Venus's old orbit, solar winds would be almost 5 times as dense as Mars is used to. Way out on Venus, the question of creating conditions for life could come down to whether you could manage to form an ocean on the planet. And that would entail bombarding the atmosphere with hydrogen. As hydrogen is introduced to the atmosphere, it would react with the carbon dioxide, leading to the formation of water. Introduce enough hydrogen and you could eventually see Venus with 80% of its surface covered in water. For this to work, you'd need a lot of hydrogen. So much that you'd probably need to find a way to harvest it from a gas giant like Jupiter or Saturn, or maybe one of their moons. Yeah, I'm not sure all this planet moving and hydrogen bombarding was really worth it. You'd still be left with only one Goldilocks planet capable of supporting life. But what if all the planets were in the habitable zone? When I say jump, you say how high. Okay, let's put this to the ultimate test by hopping around the solar system. Literally. What differences in gravity would you experience? On which planet could you jump as high as a house? And on which planets would jumping lead to your demise? This is What If. And here's what would happen if you jumped on every planet in the solar system. Every object with mass is subject to gravity. This includes you, of course. Whether you're standing on your 2 feet or lounging on the sofa, the Earth's gravity is pulling you toward the center of the planet. When you jump, the force of your muscles allows you to overcome that gravity and accelerate upward. Once you're in the air, gravity slows you down, and eventually your velocity hits 0 and you fall back to the surface. The planets in our solar system come in all sizes, so the force of their gravity differs too. Your mass would stay exactly the same, but from one planet to the next, your weight would be very different.
You guys lost a pound.
So, could you bound gracefully over mountains on one while on another you'd barely be able to lift a toe? Your interplanetary jumping experiment would begin right here on Earth. Okay, not the most exciting place to start, but a good place of comparison. If you're close to the average jumper, you should be able to squat, swing your arms, and leap about 0.5 meter high. all in about 1 second. But don't let me underestimate you. If you're an extremely talented athlete, like Javier Sotomayor, you could set a new world record by jumping over 2.45 meters. Whoa, not too shabby. Making a quick first stop on the moon, you'd find gravity 6 times weaker than it is on Earth. Well, that's because the moon has about 80 times less mass. Here, you'd only need to jump at a velocity of 2 kilometers per second to lift off the surface. And with your average jumping velocity, you should be able to jump about 3 meters high. Meanwhile, Earth's most talented jumper would be able to bound over an entire house. Okay, moving on to the rocky surface of the planet closest to the Sun, Mercury. With a spectacular close-up view and temperatures hitting 430 degrees, you'd be drenched in sweat already. Mercury is smaller than Earth. The gravitational pull is about 1/3 of what you're accustomed to here at home. So, despite exhausting conditions, you'd be able to jump about 3 times as high. Okay, let's get out of the frying pan and into the fire by taking a leap on an even hotter planet, Venus. Very similar in size to Earth, this planet has a surface gravity about 91% of Earth's. Here, you'd be able to jump ever so slightly higher than you could back home. But you definitely wouldn't want to hang out for too long in this thick, scorching hot atmosphere. So, time to cool off on Mars. You better keep your leg muscles warm though. The average temperature on the red planet is minus 62 degrees. But the good news, you'd feel lighter. Mars has about 10 times less mass than Earth, and for this reason, you'd be able to jump to nearly the exact same height as you did back on Mercury. Okay, now leaving the rocky planets behind, it would be time to test your skills on a gas giant, like Jupiter. This planet is so large that all the other planets of the solar system could fit inside it. Jupiter has very intense gravity, so you'd be feeling a lot heavier than you do right now. If you tried to jump here, you'd only be able to get a pathetic 20 centimeters off the ground. Now, if it helps your ego, this scenario would be impossible for a simple reason. It's because the gas giants have no surface to jump from, so you'd have to stay on top of your spaceship. And if I can offer some advice, don't fall off. On Saturn, you'd be surprised to find that you can jump only about 3 centimeters less than you could on Earth. Despite the planet having 95 times the mass, Saturn's surface gravity is quite similar to our home planet. Okay, now heading toward the dark, cold edges of the solar system, you'd take your leaps on Uranus and Neptune. Just be sure to avoid slipping on these ice giants. On Uranus, you'd find a relatively familiar gravitational pull. Because of this, you'd be able to jump about 6 centimeters higher than you could on Earth. Then finally, you'd reach the bleak, foggy surface of Neptune, and despite your aching muscles, you'd power through for one last jump. And that could be tough, considering the severe winds that dwarf even the largest hurricanes back on Earth. But you'd take your best shot, and struggling against the slightly stronger gravity, you'd reach 44 centimeters, roughly the same as back home. Speaking of back home, I think it's time to head back. Okay, you'd make it home exhausted.
What happened?
Too bad all the planets weren't closer together, like stuffed into the habitable zone.
Some of the planets in our solar system are gigantic, but what if they got even bigger? Let's go up the planetary size chart and see what kind of chaos doubling the size of every planet would make.
What would it be like to live on a super Earth? How big would Jupiter need to get to become a star? And would Pluto finally regain its planetary status? This is What If, and here's what would happen if all the planets doubled in size. Doubling the radius of every planet in the solar system would make each of them 8 times more massive, but you wouldn't need to worry about our solar system's great ball of fire getting bigger and hotter. For the sake of this experiment, let's keep the sun the same size it already is. But could the gravitational pull of a super Jupiter kickstart a chain of events that would result in the destruction of the solar system? Mercury. At its current size, the rocky planet closest to the sun is only slightly larger than our moon. Doubling it in size would make it nearly half as massive as Earth. And despite the fact that Mercury stopped being volcanically active 3.5 billion years ago, expanding its interior would mean all that internal energy would need to escape somewhere. So there could be some more explosive volcanic eruptions in Mercury's future. Venus. Venus is very similar in size to Earth, but one of its many differences is that its atmosphere is so thick that the surface pressure is 95 times stronger than our own. Venus's increased gravity would pull the atmosphere even closer to its surface. This could result in the atmosphere becoming so dense that walking through it would feel more like walking through water. Except you'd really be walking through incredibly thick carbon dioxide. Earth. If Earth expanded to twice its size, the first big change you'd notice is that you'd feel a lot heavier. Within seconds, you'd go from your 75 kilogram weight to feeling like you were 150 kilograms. That would be because the force of gravity pulling on you would be twice as strong. You better hit the gym to strengthen up fast because this wouldn't be easy on your body. Your heart would need to work twice as hard to pump blood around, and pressure would build up on your joints. Jumping, flying, or sending rockets into space could become a thing of the past. You'd need much more fuel, power, and money to leave Earth's surface and travel through its even thicker atmosphere. Mars. Now, if the red planet ballooned to twice its size, there's a chance you would barely recognize it. What was once a dry, desolate place could eventually transform into a more Earth-like planet with oceans, rivers, and a thick atmosphere. Mars lost its magnetic field and then its atmosphere, likely because of chemical changes inside its core. But if the Martian core got bigger and hotter, it could restart the magnetic field. And that, in turn, would protect Mars from solar winds and give it a chance at kickstarting life. Jupiter. Doubled in size, Jupiter would continue to be an intimidatingly huge planet. It would stay 318 times larger than Earth and 2.5 times more massive than all the other planets combined. And the impact of this would be so huge that it would likely shift the actual center of our solar system. You see, the planets in our solar system don't exactly revolve around the sun. No, they orbit the common center of mass, or barycenter. And thanks to Jupiter's normal size, this barycenter is actually 48,000 kilometers away from the center of the sun. But doubled up, this point in space would move even further away from the sun. You'd see material from the asteroid belt being pulled toward Jupiter or further out into the solar system. But even this big, Jupiter wouldn't be massive enough to become a full-blown star. To do that, it would need to increase to 85 times its current mass. Though it wouldn't be far off from star status. At 13 times its original mass, Jupiter could become a brown dwarf star. Saturn. With a bigger Saturn, you could kiss its beautiful rings goodbye. The monumental increase in the planet's surface gravity would upset the balance of the ring materials, as well as Saturn's 5 small moons. They'd start falling towards its surface at a higher rate. Saturn is already slowly losing its rings. Every 30 minutes, material containing enough water to fill an Olympic-sized swimming pool falls down to the planet. Uranus. Now, beyond its added heft, not all that much would change for the ice giant Uranus way out on the edges of the solar system. It would continue holding the record for the stinkiest planet. If doubling Uranus's size would mean doubling the amount of hydrogen sulfide in its upper atmosphere, this stinker might spread an even stronger stench of rotten eggs. Ugh, I wouldn't want to go near this planet. Neptune. Neptune's fate wouldn't be too different from its giant frozen neighbor. Except Neptune's increased gravitational pull could eventually lead to the disappearance of some or all of the billions of icy objects located outside its orbit. Neptune has already swallowed the equivalent of 7 to 10 times the mass of Earth in material from the Kuiper Belt. Pluto. If Pluto doubled in size, well, it could be back on track to regain its official status as a planet. If its added mass and gravity could manage to pull away debris from its surrounding neighborhood, it might just be able to rejoin the rest of the family. Alright, so it's safe to say that all the planets doubling in size wouldn't exactly bring about a cataclysmic end of the solar system. It would, however, cause a little chaos. Our solar system has 8 planets, a few dwarf planets, and more than 200 moons. But wait, are you seeing double? Or did every planet suddenly get a twin? Where would each planet's double fit in? Why would Earth 2.0 not support any life? And which planet's twin could turn out to be habitable? This is What If, and here's what would happen if every planet had a twin. The solar system has 3 types of planets: rocky, gaseous, and icy. These all formed after our sun was born from a spinning disk of dust and gas. As temperatures in the solar system rose, the inner regions were as hot as 1730 degrees Celsius, and only substances with very high melting points like iron, silicon, and magnesium could remain solid. This gave way to our rocky terrestrial planets: Mercury, Venus, Earth, and Mars. Further out, temperatures were as cool as minus 225 degrees Celsius. So the outer planets like Jupiter and Saturn attracted massive amounts of hydrogen and helium. Then beyond that, Uranus and Neptune formed out of methane and water. All these planets formed in the exact right location with the perfect conditions for what they are today, especially Earth. But on What If, since everything is possible, not only will we double every planet in the solar system, but we're also going to line these planetary twins up in reverse order. What could go wrong? I know. Pluto isn't a planet anymore. It was demoted to a dwarf planet back in 2006. But for the sake of this scenario, Pluto will make a comeback. Only this time, instead of being formed on the outskirts of the solar system, it would orbit dangerously close to the Sun. The original Pluto is about 2/3 the size of our moon, but Pluto's twin would be much smaller. Being so close to the Sun, its mantle of water ice would boil away, leaving behind only a small rocky core. Next up, you'd find Mercury in its usual first position from the Sun, but except this time, on the exact opposite side of its orbital path, it would be joined by the twin version of the ice giant Neptune. Now, looking at Neptune's twin, you'd barely recognize it. The Sun would rip gases out of its atmosphere and pull them toward the star itself. Yeah, looks like putting an ice giant right next to the Sun is a very bad idea. What were you thinking? Eventually, Neptune could be in danger of losing its entire atmosphere. Now, you certainly wouldn't see this happen overnight. Maybe if you set up the world's most epic time-lapse, you could see this unfold over the next 10 million years. Venus is often referred to as the planet of love, which would now be extra exciting because you could watch it circle the Sun with a new dance partner, Uranus's twin. This partnership would be a relatively harmonious one for both of them, and neither would see much of a change, but I need to warn you, Earth's planetary neighborhood could get stinky. All thanks to Uranus's atmosphere that carries the whiff of farts anywhere it goes. Now, Uranus's twin would be a great place for a quick visit, especially if you were looking to get rich. You might get caught in one of its diamond rainstorms and collect some bling that's been formed in the atmosphere's immensely high-pressured environment. Just don't forget your spacesuit. Next up, the Earth's orbit. You'd get to look into the night sky from wherever you are and see the spectacle that is the twin of Saturn. And you'd be in for a treat. A magnificent view of the planet's swirling yellow storm clouds. Not to mention at least 62 moons shining down on you. But just because it would be joining us in the habitable zone doesn't mean this gas giant would be able to support life. Saturn's twin still wouldn't have a solid surface, and super fast winds would whip around the planet's upper atmosphere at speeds of up to 1,800 kilometers per hour. The problem is that while you're enjoying the spectacle, this twin's gravity would start tearing our planet apart, and its moons might be set on a collision course with us. Odds are that this planetary configuration would wipe out all life on Earth. Okay, enough of the bad stuff. Let's talk about Mars. The red planet would be paired with the world that is home to the infamous Great Red Spot. Yeah, you guessed it. The twin of Jupiter is about to crash this party. The copy of the largest planet in the solar system would be located at the very edge of the Sun's habitable zone. Now, that wouldn't mean that Jupiter's twin could support life. It would still be made of gas with no solid surface, but its presence so close to Mars could cause Mars to turn into a lush, habitable world. Mars is a dry desert with no liquid water and hardly any atmosphere. Well, that's largely thanks to the disappearance of its magnetic field, which used to hold its atmosphere together. This likely happened when Mars got bombarded by asteroids in its early days. But if Jupiter's twin and its strong gravitational force were around back then, well, it could have saved Mars from those asteroid collisions. Then Mars could have kept its atmosphere, and maybe there'd be life there today. Or maybe this twin of the largest planet in the solar system would have sent even more asteroids toward Mars.
maybe even right toward Earth, meaning life probably wouldn't even have the chance to form. Okay, on the opposite side of our solar system's asteroid belt, you'd find all these pairings repeated. Starting with the original Jupiter and the twin of Mars. Things would stay pretty much the same. Jupiter would still be big and gaseous, while Mars would be cold, dry, and lifeless. And then there would be Earth 2.0. Now sharing an orbit with Saturn, you'd find Earth's twin way outside the Sun's habitable zone. Here, you'd receive 1% as much sunlight as you get back home. From space, Earth 2.0 would look like a frozen snowball version of our planet. The oceans would mostly freeze over, but that wouldn't mean that pockets of life couldn't still exist under all that ice. Deep in the ocean, close to hydrothermal vents, there could be enough heat to sustain life. The tidal motion of the water could move that geothermal heat around, allowing parts of it to remain liquid. Next on the list, the twin of Venus, located right next to Uranus and 27 times further away from the Sun than it is now. This would cause its temperatures to drop. The original Venus is known for its scorching hot surface temperatures that can be as high as 475 degrees Celsius. Even this far from the Sun, the Venusian twin could still retain some of its warmth. But you wouldn't be able to move there just yet. Its thick atmosphere would be full of lethal amounts of carbon dioxide and sulfuric acid, so you'd have to terraform it first. Finally, reaching the outer edge of the solar system, you'd find Mercury's twin circling the Sun in the same orbit as Neptune. While the original Mercury is the second hottest planet, this world would be a frozen rock. It would also look eerily similar to our moon. Okay, that's the end of our journey through this crowded version of the solar system, but I wonder what things would look like if it was all a little closer together. Whoa! Our solar system is plunging into chaos. Better hang on tight, the planets are getting knocked out of orbit. What could kickstart this epic chain of events? How would this impact each and every planet? And how could it possibly make Earth even more hospitable to life? This is What If, and here's what would happen if the planets were knocked off course. The solar system's planets have remained in stable orbit around the Sun for billions of years. And they'll likely remain so for at least another 100,000 years. Thanks, Newton's first law of motion. But the forces that disturb this balance could already be underway. Like a giant rogue star not bound to any galaxy, or a wandering black hole. And bad news for us, our universe is littered with agents of chaos, ready to disrupt our planetary neighborhood at any moment. It would all start with Neptune. Neptune doesn't need to be knocked out of alignment much for bad things to happen. If this icy giant's orbit changed by even 0.1%, it could trigger a series of events that really mess things up. With Neptune's orbit in flux, it would begin to influence the orbits of its neighbors, and sooner or later, each planet's disturbed orbit would unleash total chaos in our solar system. At first, you wouldn't see much from Earth. Only astronomers would notice the slightest changes in planetary orbits. They'd be the first to know that something really wrong was about to happen. These disturbances would build up and eventually they'd reach a tipping point. Neptune's changed orbit would affect Uranus. these two ice giants would come dangerously close to each other. And then they'd pluck Saturn out of its orbit. This trio could be ejected out of the solar system entirely, and none of the other planets would be safe from this ensuing cosmic pandemonium. Because as Neptune, Uranus, and Saturn were on the way out of our planetary neighborhood, they'd shove the biggest planet in the solar system off its rails, Jupiter. Instead of revolving around the Sun in an almost perfect circle, Jupiter would now have an erratic elliptical orbit. Sometimes it would be closer, and other times it would be further away. And this would impact Earth's orbit as well. One peculiar effect would be a new kind of global warming. Our new orbit would result in the coldest parts of the planet reaching more pleasant temperatures. As this celestial domino effect continued, Venus's orbit would change too. If it started to spend more time further away from the Sun, would there be a chance that it could cool down enough to become habitable? Well, not exactly. Venus's scorching temperatures run as high as 462 degrees Celsius. And that's not just because of its proximity to the Sun. It's due to its runaway greenhouse effect. Venus's thick atmosphere already reflects about 75% of any incoming radiation. A relatively small shift in its position wouldn't be enough to offset the greenhouse gases that keep it sweltering. On the other hand, Mercury wouldn't be let off the hook so easily. A new orbit could lead to a close encounter with the Sun, and that could eject it from the solar system as well. All these planets being forced into new trajectories could also lead to something a little more dramatic than just close encounters. They could collide. Yeah, Venus and Mercury could slam into each other and form a new planet. Well, brace yourself for the possibility of a full-on collision with Mars. If that happened, it would be bad news for you. If Mars crashed into Earth, well, there would be no way you'd survive this impact. And you'd have nowhere to run from this doomsday scenario. Now, should you be worried about any of this? Well, most flybys close to our solar system, like a rogue star, probably wouldn't lead to such a dramatic destabilization. Anything we might consider to be a threat only occurs once every 100 billion years. Body-crushing pressure, toxic atmospheres, unbearable temperatures. That's what would be in store for you if you visited other planets in our solar system. But what other environmental hazards would you encounter? Which planets would be the safest and which would be the most dangerous? And how long could you survive on any of them? This is What If, and here's what would happen if you spent a day on every planet in our solar system. Before you get started on your journey through the solar system, you should pack a bottle of water. Earth is the only planet known to have consistent bodies of liquid water on its surface, so if you pack enough, you could probably survive a few days just about anywhere, right? Well, sorry to say, I've got some bad news for you. Let's start with a visit to Mercury, the smallest planet in the solar system. This rocky, crater-filled planet is only slightly larger than our moon, and it's located extremely close to the Sun at a distance of 58 million kilometers. Now, even though a day on Mercury equals about 59 days on Earth, your trip wouldn't last anywhere near that long. Due to this slow rotation, you could land on the sunny half where the temperatures reach 430 degrees Celsius, or maybe you'd aim for the dark side where temperatures drop to minus 180 degrees Celsius.
Your best bet would be to find a cozy spot somewhere in between. But with an atmosphere mainly composed of oxygen, sodium, hydrogen, helium, and potassium, good luck breathing for very long. Even in this middle ground, you wouldn't likely survive more than 2 minutes. Okay, let's check out what a day would be like on the second planet from the Sun, Venus. Well, you should expect a very warm welcome because surface temperatures are a piping hot 475 degrees Celsius. And one day on Venus lasts 243 Earth days. Unless you've got an impossibly robust spacecraft, you couldn't get very close to the surface. And even if you did, you wouldn't last very long. Venus has a thick and toxic atmosphere with 154,000 times more carbon than the atmosphere of Earth. And it's shrouded in yellowish clouds of sulfuric acid. You could say the Venusian atmosphere is a runaway greenhouse effect. Between the toxicity and the heat burning you to a crisp, you wouldn't survive 1 second on Venus. Now, let's skip on over to Mars. Unless you wanted to stop back on Earth for a couple breaths of fresh air. On Mars, you'd find comfort in a day that is a little over 24 hours. What you wouldn't find comfortable is an atmosphere of carbon dioxide, argon, nitrogen, and a little bit of oxygen and water vapor. The surface of Mars is cold, with an average temperature of minus 62 degrees Celsius. Combine the low surface temperatures with the unbreathable air, and you wouldn't survive much more than a few minutes here either. On the next planet, you wouldn't be able to reach the surface. That's because there isn't one on the gas giant Jupiter. This planet is more than twice as massive as all the other planets in our solar system combined. And its atmosphere is primarily hydrogen, helium, and cold, windy clouds of ammonia and water. Jupiter might be bulky, but it rotates fast. One day lasts a mere 10 Earth hours. And because it's so fast, Jupiter's atmosphere has strong jet streams. Plus, the Great Red Spot that is actually a storm, bigger than the size of Earth. If you fell into the planet, you would enter the atmosphere at a whopping 49 kilometers per second. And as you kept falling, the atmosphere would become denser and more turbulent. You might feel like you were slamming into a wall again and again. If you made it 692 kilometers down, you would find pressure levels higher than at the bottom of the Mariana Trench, the deepest place on Earth. If the pressure didn't kill you, the temperature, which averages minus 145 degrees Celsius, certainly would. You wouldn't survive on Jupiter for 1 second. Now, if you continued on to Saturn, you'd find another gaseous giant without a surface, and like Jupiter, a day lasts about 10.7 hours. Here, you would experience deadly strong winds, reaching up to 1,800 kilometers per hour. With an unbreathable atmosphere made of hydrogen and helium, Saturn is incapable of supporting life. Maybe you'd have more luck on one of its moons, like Titan or Enceladus. These two moons have internal oceans, which could theoretically support life. Okay, moving on to the first of the ice giants in our solar system, Uranus. No surprise here that it also has an unbreathable atmosphere of hydrogen, helium, and methane, which gives the planet its signature blue-green color and the stink of rotten eggs. There are some other unusual hazards on Uranus you'd need to be prepared for, such as mysterious flares of X-rays and lethal diamond rain. Yeah, you heard that right. Highly compressed diamonds of carbon atoms raining down from the atmosphere. But don't worry about that. The immense pressure on this planet would kill you in less than a second. Alright, last but not least, Neptune. A dark, cold planet with supersonic winds as strong as 2,000 kilometers per hour. That's faster than the top speed of a fighter jet. So if the pressure didn't kill you, those supersonic winds would probably do the trick. A day on Neptune would last for 16 Earth hours, but your life there wouldn't last a second. Okay, there it is. So in case it isn't clear, Earth would be the only planet you would want to visit anytime soon. Just about anywhere else, you could look forward to a deadly cocktail of high pressure and toxic gas. I mean, that is, unless we terraformed Mars, creating a second home for humanity within the solar system. But that's a story for another What If.
We've heard about terraforming the Moon and Mars as we attempt to colonize space. But what about Venus?
If we did manage to terraform our neighbor, one day it could look like this.
Could we live here one day? How different would it be from life on Earth? This is What If, and here's what would happen if we terraformed Venus. Believe it or not, Earth and Venus